But the word elasticity obviously refers to something stretchy, and a rubber band with some elastic. And that's kind of what this represents, especially for demand. Well, it's supply too. But demand elasticity represents how consumers will be stretched to the limit in terms of when a price is changed. How responsive they're going to be to a price change, or how sensitive they're going to be to a price change. So the emphasis for the notes and for the chapter actually is the elasticity of demand. Well, there is elasticity of supply. I do spend a couple of slides on that. There's even another one called income elasticity. I think I got one slide on that. But the emphasis really with elasticity is always about demand, consumer responsiveness. And that's really what the definition is and what the question answers. How responsive are consumers to price changes? So how much you're going to stretch till you break and say, heck with that, I'm not buying that thing anymore because the price is too. Did you see the price of the Super Bowl ticket? They had a kind of comparison with the first Super Bowl ever played, 1966 maybe. It was $7.50 on the face of the ticket. Yesterday, $2,500. That's what it said. Now I don't know where that ticket was, but $2,500. Well, price inflation. I would definitely break there. I would not want to pay that. But maybe $7.50 in 1966 was a lot of money for a lot of people. But it's how responsive you're going to be to a price change, whether it's gas prices or your dentist. And I do talk a little bit about dentistry. Maybe your teeth cleaning, what the price is of that, and so how responsive you would be if they raised the price on you. You're going to be responsive for the most part. Depends on a couple of factors, and we'll talk about those throughout. The definition of the price elasticity of demand is a measure of the responsiveness of buyers and sellers to changes in price or income. Now, that kind of is a broad definition, but basically the word responsiveness is the key word. How responsive you are going to be to a price change. That means the price going up or going down. Here is the calculation, and there is a little bit of math in this chapter. So you might need a calculator. This will be a little helpful to have one. You don't have to go out and buy a $100 calculator. Just one that can subtract and divide and add. I think that's about it. There's no multiplication, but just a simple function. You just can't use your phone on the test. Which I don't let you use your smartphone as your calculator for the test. Okay, so unless you're good at math, it might be helpful to have a little calculator. I can do a lot of these stuff by hand, and many of you probably can too. So nothing but subtract and divide. The price elasticity of demand, we use a coefficient. The E is for elasticity, and the small case d, or sometimes a capital D, it depends on what book it comes out of, is for the word demand. So it's a coefficient. We use the phrase coefficient there as the resulting calculation. So the coefficient is the change, percentage change, in quantity demanded divided by the percentage change in price. So I'm reading it how those symbols are. Percentage change, that's a delta sign, by the way. Everybody knows what that is mathematically. It's a little triangle with a delta sign, which means a change. Percentage change in quantity demanded divided by the percentage change in price. And that's the basic calculation. Well, I'm going to do an example here. If my board will erase nicely. I'm not sure it will. No. I'm out of that spray too. I need for the example is just a couple of prices and quantities there. I'm going to calculate this percentage change, just kind of like this formula says. I want to use this example. I know there's another one here on the slide, but let's go ahead and use this. If anybody remember how to do a percentage change in math? Like a basic percentage change calculation. Like if you go from $10 to $12, what's the percentage change? I know it's a $2 increase, but what's the percentage change? Anybody know how to do that?
12 divided by 10.
Okay, I always remember it as the new amount minus the old amount divided by the old amount, and then of course times 100. That'll give you the percentage. So if in that example, 10 and 12, the new amount is 12 divided by, or subtracting the old, minus 10, divided by the 10 times 100. That should be, what, 20%? So 20% increase. 20% increase on that example. So you can do the same thing with these. All you need is two numbers to go to a percentage change. And the amount, let's do the percentage change for quantity demanded first. Let's do that one. What's the new amount? Let's just say let's say this is the new amount. This is the old. So the new amount is 80 minus the old amount divided by the old amount times 100. So what's 40? Negative 40. Negative 40 divided by 120 times 100. What is that? 33% negative. I believe it's rounded. I mean, you're going to use a repeating decimal. And the other thing about elasticity of demand, we drop the negative sign. It says it here. The price elasticity of demand is always negative. Okay? But economists ignore the minus sign and present the absolute value of the elasticity coefficient. So again, absolute value would be the two vertical lines. Basically, we drop the negative or the minus sign and just have 33%. So that was a 33% decrease in quantity demanded. How about percentage change in price? Same thing. We're going to take the new, we're going to use this row as the new, this row as the old. The new amount is 6, the old amount is 4, divided by 4 times 100, and that is 2 divided by 4 is 0.50 times 100 is 50%. That was a 50% increase in price. So in the example, if the quantity of videotapes rented falls by 3% when the price is raised by 3%, or by 1%, then the price elastic demand is 3 divided by 1, or 3. So if I were to just plug this in to the formula that we have over there, we would have the elasticity coefficient percentage change in quantity demanded, which was 33%, divided by the 50%, and that is 0.66666, right? Something like that. Probably would round it to 0.67, depending on the decimal place. And that is what you would list the coefficient as, a decimal like that. It's not a percentage. That's just a number, a decimal number in this case. Does anybody see a problem with this formula and the way you do it? Kind of a loaded question. There is a problem with this. Because what if I changed these two things? What if I said that the new amount was the top row and the old amount was the bottom row? Then you're going to get a different answer. So what economists have come up with is an average. Rather than, and if I did this the other way, if I turned it around, I think it ends up being 1.5. So it's not 0.667, it's 1.5. Because basically this would be on top and that would be on bottom. That's what would happen if you did it a second way, because you don't know which one is new and which one is old, or which one was the original amount, which one was the new amount. So we ended up using what's called a midpoint method. I believe that's on the next slide. It's called a midpoint or average method. And what you're doing is just substituting this little box here, this little part here, you're substituting in for the top, and you're substituting this box here for what's on the bottom. That's all. So if I rewrite it, the whole thing, I'll write it over here. For the elasticity coefficient, it would be the Q2 minus Q1, this will be the top of it, divided by Q1 plus Q2, divide those two items by 2, that's where you come up with the average. Then on the bottom would be the price, so price P2 minus P1, and divide, take that, the two prices, and average those, divide by 2. So I've just taken that little portion and just substitute them in for the top and bottom. It says in both cases the denominator is the midpoint between the two quantities, whether it be quantity or price. And if you use this data, we'll use this again, we're going to come up with a completely different answer. As you might expect, it's going to be somewhere between 0.667 and 1.5. So let's do it. Let's just kind of plug in the numbers here. Q2, well, it really doesn't matter. You're just adding, just taking the, one way I like to show it too is the top is the change in Q, okay? And this bottom is the change in P. The bottom, top with the bottom portion. So the change in quantity there, what's the change in quantity of our data? 120 and 80, what's the difference? What's that change? No, so you don't have to put the negative.
40.
Change is just a 40. Okay, so 40. And what is Q1 plus Q2 divided by 2? So you add the 2 up, the 120 plus the 80, 200, divide by 2, you get 100. 120 plus 80 divided by 2. The bottom, P2 minus P1, I like to just say change in P. What's the change in P? It's just 2. The difference between 4 and 6 is 2. So 2 is on the top. And the prices would be the average there between 4 and 6,
5.
which would be 5. So you're taking 4 plus 6 divided by 2. So bringing it out a little bit further here, the top is 40, the bottom is 100, this is 2, and this is going to be 5. And then just two more steps actually. I just put things in decimal. So this top number is 0.4 and the bottom number is 0.4. 2 divided by 5. And 0.4 divided by 0.4 is what?
It's 1.
Okay. So that's our coefficient. We just calculated it using the midpoint method. You're going to have to do that on the test. I'll give you the, a table like this. I think I do it a couple of times where you've got the table data, and you just calculate it using the midpoint method. I don't want you to use the old, the traditional thing. I want you to use this formula. Okay, that's the more accurate measure. Well, at this point, you probably say, well, what does this number mean, right? It's 1. Well, there is a kind of a benchmark for the numbers. If it's equal to 1, we call that unit elastic. Ooh, whatever. I didn't skip one, did I? I don't think I did. So with the second bullet point, if we found that this coefficient E sub D is equal to 1, we call that the unit elastic point. If we found it to be greater than 1, that would be up here, we call that the elastic region on the demand curve. And if we found it to be inelastic, the coefficient will be less than 1, but greater than 0. Nothing's going to be less than 0. I mean, it's always going to be a positive number because we're going to drop the negative sign. We're always going to use the coefficient or the absolute value. Students can, let's say, I like to refer to the inelastic region first and kind of refer to the word inelastic with another word. Whenever you see that the coefficient is less than 1, which is here, inelastic, then this corresponds, inelastic corresponds to unresponsive. And it helps me to remember it. Inelastic means unresponsive because it starts with an IN. Unresponsive starts with a UN. That's what it means. It's unresponsive to what? A price change. You're unresponsive to a price change. If we found it to be less than 1, then whatever product we're talking about, this would be a product here. Like change went from $4 to $6, and the quantity fell because of that. If the price of peanut butter went from 4 to 6 per jar, quantity would fall because people are based on our numbers, it's unit elastic. We're kind of indifferent there. It's in between. It's called the unit elastic point. But if it had been less than 1, like 0.5 or something, then I would have said we're very unresponsive to the price change, and we could care less what the price does. If the price goes up, we're still going to buy it. We're still going to buy the peanut butter. So I believe that's the next part. Yeah, perfectly inelastic consumers are extremely unresponsive to price changes. Gasoline is another one. Gasoline goes up, guess what? You don't care. You do, but you don't have a choice, do you? You typically are going to have to buy. You're going to grumble about it, complain about it. You might try to conserve a little bit, but you're still going to pay for it. You're unresponsive to the price change, which might clue you into some of the products that are unresponsive, things like necessities. So it doesn't matter if it's food, general food, to survive, food, water, shelter, that kind of stuff. The price, for the most part, you're going to be unresponsive to changes in prices. Perfectly elastic, which would mean not unresponsive, but responsive, meaning that you're going to respond to price changes dramatically. You're going to say, well, heck with that. I'm not buying that. I'm going to buy something else. I'm going to buy a substitute, something that's lesser priced. You're going to be very responsive to price changes. And then, of course, the one that we calculated here, we found it to be equal to 1. it's called unit elastic. That means the response is equal to the change in price. So there was a perfect, in our example, with our numbers here, percentage change was exactly the same on both top and bottom. Because of a 40% increase in price, we had a 40% decrease in quantity demanded. So it was just equal to it. All right, so when we come back, I'm going to stop here for today, but when we come back on Wednesday, I'll maybe do another example, another midpoint example, and we'll continue with all of this in practice. I'll see you Wednesday.